Compressing and archiving. Hackers often need to download and install new softwares, as well as send and download multiple scripts and large files. These tasks are easier if these files are compressed and combined into a single file. If you come from the Windows world, you'll probably recognize the concept from the zip format, so which combines and compresses files to make them smaller for transferring over the internet or removable media. So there are many ways to do this in Linux, and we look at few of the most common tools for doing so in this lecture. So we'll also look at the ddelete command, which allows you to copy entire drives, including deleted files, onto those drivers, actual drives, not drivers. So what is compression? So the interesting subject of compression could fill an entire course by itself. But for this course, we only need a rudimentary understanding of the process. Compression, as the name implies, makes data smaller, thereby requiring less storage capacity and making the data easier to transmit. For your purposes as beginning hacker, it will suffice to categorize compression as either loosey or looseless. So loosey compression is very effective in reducing the size of files, but the integrity of the information is lost. So in other words, the file after compression is not exactly the same as the original. So this type of compressions works great for graphics, video, and audio files, where a small difference in the files hardly noticeable, like MP3, MP4, and PNG and GPH are also all lossy compression algorithms. So if a pixel in a PNG file or a single note in a MP3 file is changed, your ear is unlikely to notice the difference. Though of course music aficionados will say that they can definitely tell the difference between an MP3 and uncompressed FLAC file. So the strength of lossy compressions are it's efficient and effectiveness, but the compression ratio is very high, meaning that the resulting file is significantly smaller than the original. However, lossy compressions is unacceptable when you are sending files or software and data integrity is circular. For example, if you are sending a script or document, the integrity of the original file must be retained when it is decompressed. So this lecture focuses on the lossless type of compression, which is available for a number of utilities and algorithms. Unfortunately, lossless compression is not as efficient as lossy compression, as you might imagine, but for the hacker, integrity is often far more important than the compression ratio. Tearing files together. So usually the first thing you do when compressing files is to combine them into an archive. In most cases, when archiving files, you will use the tar command here. So let's open here. So you will use tar command. So tar stands tar here. So tar stands tape archive here. So a reference to the prehistoric days of computing when systems used tape to store data, this means tar here. So the tar command creates a single file from many files, which is then referred to as an archive, tar file, or tarball. For instance, you say you had 3 scripts files like the here, for example, touch here, touch here, for example, tech beans 1.c hash here, touch tech beans 2.python here, tech actually touch tech beans 3 dot here, for example, out here. As you can see, we created files, but they are empty files. So if you navigate the directory that holds them and perform the long listing, you can clearly see the files and details you'd expect, so including the size of the files here, as you can see here. ls la here, actually ls l is okay here. So as you can see, we created 3 files. Let's actually copy them to folder here, and let's change it with our text editor. Actually, let's example proj here, and let's copy these all here, and here let's open here and put them put inside them something here, just an example ch file here. Here, as you can see, we created a lot of it here, and let's open this as well. Python file here, as you can see here, and let's open here and just that out file sometimes uses for C compiled C scripts here, or programs here. Yeah, let's as you can see here, we have a new example profile here. So cd example here, and lsl here. As you can see here, there's a different files. So let's say you want to send all 3 of these files to another hacker you are working with on a project. So you can combine them and create a single archive file using tar command here, tar cvf. So we are entering the name of our file here, techbeans project.tar here, and we are assigning our files here without comma here. So first file here, techbeans1ch, techbeans3 out here, and techbeans2 Python here. Oops. As you can see here, we compiled, we created tar file. So let's break down this command to better understanding. So the archiving command is a tar, and we are using it here with 3 options, as you can see here. So the C option here means create. V here, which stands for variables, and it's optional. You can, it's not mandatory here. So it's for outputting these files, which files is created in tar files. And F command here means write the following file here. So the last option will also work for reading from files. Then we give the new archive the file name you want to create from 3 scripts here. As you can see here, we named it the techbeans project here, tar. Of course, in full, this command will take all 3 files here and create a single file. So here techbeans project tar out of them. So when you do another long listing of the directory, you will see that it also contains a new tar file here, as you can see here. So note the size of the tar file is here 399360 here. So when the 3 files are archived, tar uses significant overhead to perform this operation, whereas the sum of 3 files before archiving here, let's calculate it here. So we will calculate these 3 files here. Let's see it. the first TechBeans1 C hash here plus 31863 here plus lastly is our out file 357304. As you can see here, our type file is 393946 here. So, but in here 399360. So this tarball here actually. So this is greater than. So this is greater than our total of sum of these files. So in other words, the archiving process has added almost let's minus here or here minus 399360 here. So as you can see here, the tar process is added almost 5414 bytes to it. So although this overhead can be significant with small files, it becomes less and less significant with larger and larger files. So we can display those files from the tarball without extracting them by using the tar command within the tcontent list switch here, tar tvf here and TechBeans project here. Actually, let's see how many minutes we have. Yes. So can you see it actually? Yes. So here we see our 3 original files and their original sizes. So you can then extract those files from the tarball using tar command within the x, which is extract switch as shown here. For example, tar xvf here, xvf here. Let's first ls la here. So now tar for comprehending these files here, xvf here, and TechBeans project. As you can see, we extracted these files here. So we extracted these files. So let's delete these files here, and I will see how to extract it here. As you can see here, we extracted these files from TechBeans project.tar file here, as you can see here. So here, because you are still using the V switch, this command will show which files are being extracted in the output here. If you want to extract the files and to do so slightly, meaning without showing any output, you can simply remove these V, which is verbose command switch here. So here xf and nothing output, but our files still extracted. So the files have been extracted into the current directory. You can do a long listing on the directory to double check. So note that by default, if an extracted file already exists, tar will remove the existing file and replace it with the extracted file here. So in later lecture, I will show you compressing the file. So I'm waiting you in later lecture.